Good evening, young people. It's Mrs. Rains, and I'm here to kind of talk a little bit more about what we were talking about today. For those classes that were rushed at the end, please make sure you watch this. Hopefully it won't be too long, but it's about the topic that we were talking about today in class and we were trying to introduce. That we're going to get a little more information on tomorrow, but you need to make sure that you know how to do this because we're moving forward tomorrow. We're not going to go over how to do this. We're moving forward with what we have to do. We also have a quiz tomorrow, so please make sure that you're prepared for that. So, electron configuration. The first thing that we need to talk about with electron configuration is the same thing that Bohr told us. Bohr said that things have to be filled from lowest energy to highest energy. So, in that particular case, we have to make sure that we know what that means. What does it mean for lowest energy to highest energy? So, we use something called the diagonal rule. And the diagonal rule is kind of a memory device that was kind of developed to be able to understand what's lowest and what's highest. So it's based upon the Aufbau principle. The Aufbau principle says that electrons have to fill from lowest to highest. I cannot fill an energy level that is higher before all of the energy levels that are lower are completely filled. So I can't fill a 2s until a 1s is full. So we get this idea that there is an order that we have to do. So the Aufbau principle is the thing that is talking about that. So what is the diagonal rule? Well, we start out and we write the energy levels from top to bottom. So we know we have 1, 2, 3, 4, 5, 6, 7. Then we want to know what orbitals are in those energy levels. So we have a 1s, we have a 2s and a 2p. We have a 3s, a 3p, and a 3d. We talked about this today in class. Okay, we also talked about the fact that when we get to 4f and 5f, why don't we have anything else? Why don't we have a 6f and a 6 or 7d and a 7f? Why don't we have a g? Well, the equation predicts that those are be there, but our periodic table is finite. It doesn't have an unending, limitless amount of elements. We have an ending for our elements right now. And until we have more elements that last for longer, we now have a point at which we can't go any further. So while they're predicted, this is where we are. This is what we have on the periodic table. And if you follow along, just like we did today in class, you will see this. So if you look, 1s is hydrogen and helium, 2s is lithium and beryllium, 2p is boron through neon, 3s is sodium and magnesium, 3p is aluminum through argon. 3D is a little bit tricky because we have to skip a couple of elements because the 3D comes in that squished portion, 3 through 12 columns that get squished because remember that's the fourth period, but the energy level is period number -1 there, so it's a 3D. And if you move down the periodic table, you'll start seeing that pattern forming. So now, how do we know what the diagonal rule says? Well, we draw a diagonal arrow from the top right to the bottom left, starting at the top. So the first arrow is there. Okay, so here are our arrows. Blow your mind, right? Okay, so our arrows come in and you can see the order is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. Now I gave you something that I call the checky sheet. That checky sheet follows the diagonal rule order. So you don't have to be concerned about this. I'm not necessarily going to test you on the diagonal rule. I am going to make sure that you understand that we go from lowest to highest. So you might be asked about Aufbau and what he says in terms of energy levels of elements, but I'm not going to necessarily test you on this, except that you're probably going to have to draw an electron configuration, so you're not going to have your checky sheet. But I got something else for that tomorrow, okay? So no big deal. So take a moment right now, stop the video, keep this up, and check that your checky sheet is in this very same order. You'll notice that the 7p orbital, the 7p sublevel, is the highest in energy, and the lowest in energy is the 1s. Sorry about the ding-ding. Okay, so here we go. How many electrons can be in a sublevel? We already know this. 1 orbital, 2 electrons, 3 orbitals, 6 electrons, 5 orbitals, 10 electrons, 7 orbitals, 14 electrons. We already know that. That's the maximum number that can be there. However, if we don't have that many electrons, we stop with the number of electrons we have. We cannot add electrons. We do not have 2 orbitals. We can only have electrons for what we have. If we don't fill an orbital, it remains unfilled. Okay? So we know where the S, P, D, and F blocks are on the periodic table. 2 elements, 6 elements, 10 elements, and 14 elements. Pretty simple, huh? So the periodic table tells you everything. That's what I was telling you today, right? So we also have the orbitals and their levels. Notice, here we go in the center. Where's my cursor? I don't know, I can't find it. Here we go in the center, okay? We see 3D, 4D, 5D, 6D, and then right down here we see 4F, 5F. Notice sharp, proximal, diffuse, and fundamental. I told you there were names. I don't remember them. You don't have to remember them. It's not that important, okay? So electron configurations, how do you do this? It's counting. We count all the electrons in an atom. We look at the periodic table. How many electrons is an atom supposed to have? Well, it should be the same as the number of protons. The protons are the same as the atomic number. Should be easy. We're not worried about the nucleus. The nucleus doesn't matter to us because we cannot do nuclear chemistry safely. So we need to worry about the electrons, and we'll find out a little bit more why later. So don't panic about this. We will have electron overload before we're all said and done, because you will understand exactly why we're talking about electrons before the end of the year, okay? You must go in order, so you must follow the Aufbau principle, meaning lowest energy field first. 2 electrons per orbital maximum. Let's go back for just a second. We also need to make sure that we're following Pauli's exclusion principle that says 1 electron has to go in one direction and 1 electron goes in the other. That's pretty important. So we have to make sure that we do that. We also have to make sure we follow something else, but I think I'll talk about that in just a second. So here we go. So carbon has 6 protons and 6 electrons, so we start to fill. Aufbau says we start with 1s. So we start with 1s. There's 1, 2. Then we go to 2s, 3, 4. Then we go to 2p. Now, we don't do this. This is not right. That's not okay. This is the one that's right. So if we go back here, I had 2 in the same orbital. Well, this is the problem. Hund's rule says I can't do that. I cannot put 2 electrons in a single orbital without first filling the rest. It's like saying a parent who has 3 children about the same age, and they go into a store and they buy the youngest child something, but they don't buy any of the other children anything, and nobody's done anything wrong. Well, you wouldn't find that very fair. Or if everybody got one thing that was the same and then the oldest child got the big special thing, you would all be mad about that if you were in that family. So we don't do that. We always put 1 electron in an orbital, and this is the ones with multi-orbitals. So the P's, the D's, and the F's apply. Hund's rule applies to this. So we don't fill it like this. This is not right, but we do fill it like that. Okay, so we have to put 1 electron in per orbital, per space, before we can put a second one in. Okay, so what is the electron configuration? Well, let's look back. We have 2, excuse me, we have 2 in the 1s. We have 2 in the 2s, and we have 2 in the 2p. So our electron configuration is right here. 1s2, 2s2, 2p2. The big numbers, the 1s and the 2 2s back here, that's the energy level. That's the principal quantum number n. The s's and the p are the L, the space that it's being applied to. The little 2s, the subscripted 2s here, they're not squares. We're not in math. It's not 1s squared, it's 1s2. But those are the electrons, and if we add them up, 2 plus 2 plus 2, that equals 6. So that's the electron configuration. So the next slide is going to ask you to try some. I'm not worried about that. You have some homework to try some. Use your checky sheet. Make sure that you're thinking about what you're doing and not just playing with what you're doing. Try to do it right, because that's important. All right? We'll get some more information tomorrow. So, I'm sorry, I was going to explain some more here really quickly. So the 2 is the energy level, the P is the sublevel, and this is the number of electrons. So we just talked about that just a second ago. Okay, so write the following electron configurations and try them out. Thank you very much. I will see you tomorrow in class.